I'm trying to tell the story in the words of the people who basically were the major actors. It's an intellectual history of the idea of evolution, but particularly about the nature of species and how species evolve through natural means rather than supernatural means. The person that I learned was perhaps even more critical than anybody was Isaac Newton. He firmly believed that there was a natural causal explanation for absolutely every natural phenomenon that you could pinpoint, you could show, you could demonstrate.
The scriptural emphasis on the creation story in Genesis was a positive facilitator of modern geology in that respect, because it encouraged these early people in the 17th century and 18th century, encouraged them to think in terms of the historical development of the Earth, so that once they had also accepted the idea of a very long time scale, then you could have a very long history of the Earth. But it was a history. Earlier on, if you were going to be scientific about the Earth, you tended not to be historical. You were looking for timeless laws of nature.
The most important person that got the ball rolling for evolution was Lamarck, who was widely disparaged in our culture and in our times. When I read his 1801 book on invertebrates, he had a little section on fossils, and he said that 3% of the species that he knows as fossils are still alive today off the coast. His colleague at the Jardin des Plantes was Cuvier, and Cuvier was very important for many reasons, but one of the most important ones was he was convinced of the reality of extinction, to the point where he said that absolutely no animals that you find as fossils, animals or plants, are still alive today. Lamarck said no, only 3% of my things are still alive, but it's not because they went extinct, it's because they slowly changed into the species that we have today. And also he said, and if you look hard enough and you go laterally, geographically, you'll see them also graded. And so what we're missing is data that shows what the intermediate steps are.
Lamarck's idea of perpetual gradual change made no sense of the obvious adaptation of individual species to particular environments. So sort of stability of species was not adopted for creationist reasons, but simply because that was the best biological explanation. And Cuvier was obviously a very eloquent advocate of that.
Giambattista Brocchi was an Italian geologist who studied Italian fossils, particularly those that he found in the sub-Apennine hills. What he did was collect data from the modern Adriatic Sea where modern species were living, and compare them with his data from tertiary fossils. What he found was that about 50% of the species were still living. We could say that Brocchi had a third way to the history of species, which was separate and distinct from Lamarck's and Cuvier's.
First of all, he says it's kind of pointless, though, to just study the shells on the modern beaches, you know. Except that tells you what's alive now, and you can match them up with the fossils that he's got. But he also said, likewise, it's a waste of time, basically, to go to the older rocks and study genealogies of species, I guess he said, now long since gone, that have nothing to do with understanding the origin of the modern species. The famous thing that Brocchi said was that species are like individuals. They have births and deaths through natural causes. He also felt that species do not change particularly, so the ideas of Lamarck, if you look at species in the fossil record through some layers, obviously the passage of time, you never find what Lamarck was predicting that you should find. Basically, the species are the species.
It seems more and more that there were lots of other theories and speculations floating around internationally in the early 19th century for other kinds of natural explanation of species origins. I think there's very, very little evidence for a belief in sort of real sudden creation from nothing, as it were, a new species. I don't think any serious thinker adopted that. Most of them said, no, well, it's a mystery.
Those are the watchwords for the beginnings of modern evolutionary theories, to come up with a natural causal explanation for the origin of the species that we have around us today. And so everybody thought, well, the fossils would be important for this. And the best and most easily collected fossils for this purpose are mollusks. Not fossil bones and stuff. It's very rare you get enough of that material.
Think about those questions, why don't I try writing about them? I think that long-term perspectives are really valuable generally, and I think that's one of the main things historians of science have to offer.
Geology was such a new science in the early 19th century and really exciting for people, for one thing. It's almost hard for us to imagine now how the very idea of going out and collecting fossils or doing field work was something people just fired up their kind of idea that, you know, this would be a chance to see big landscapes, it would be a chance to explore the wilds of nature. So that when it came, for example, to the Geological Society of London, was it going to be called a mineralogical society, or was it going to be called a geological society? Geology had this much broader sense of studying the entire Earth and its past history. So there was this kind of idea that geology was romantic from that point. It promised a kind of cosmic understanding of the depths of what went on in the Earth, the past of the human race, the past and indeed of the entire planet. And this was something you could get through to geology. So even today, for practicing geologists, they often have a kind of, the reason they study the subject, the reason they love it, the reason they enjoy looking at fossils or understanding the past, has many of the emotional components that we would identify as effectively being romantic. If you would have gone to Darwin's back garden at Shrewsbury, they had a little chemical lab in the back of their house, and there they analyzed minerals, and Darwin had his own mineral collection, a little cabinet of his own. He was really interested. He was interested in the first memory he has that he relates to natural history of is picking up stones. So Darwin is quite interested in these questions from the beginning, and it's an interest that really takes off in Edinburgh.
The next thing I can see in the story, though, is the review of Brocchi's monograph by Leonard Horner, who was a geologist, British geologist, actually Scottish geologist. He says, Systems are speculative, and I'm not going to basically bore the reader or trouble the reader with repeating Brocchi's speculations. But then he said he hastened to add that he does realize that the ultimate reason for doing any of this geological or paleontological work is to come up with a system, to try to form an understanding in general, simple terms about what the processes of Earth history and the formation of the fossil record and so on, the history of life, is really all about.
The idea of species as individuals survived in the early 19th century literature, particularly in Scotland, in Edinburgh.
Perhaps in Edinburgh the analogy was already in circulation without even Brocchi's name attached any longer to it, so that people were beginning to use the analogy. We know that the book, a copy of the 2 volumes of Sub-Apennine Fossil Conchology, to give it its English translation of 1814, was in the university library.
There was a small group of people in Edinburgh who were called the Edinburgh Lamarckians. One of them was Robert Grant, and the other one was Robert Jameson. They were both physicians teaching at the medical school. These guys turned out to be very important to Darwin, who began being a student in the medical school in 1825.
Well, this is the square where John Berkeley's extramural anatomy school was based. So this would be a very familiar place to many, several generations, in fact, of Edinburgh University medical students. Not only did Knox run the medical school here, but also it was here that Robert Grant taught in John Berkeley's anatomy school. He taught invertebrate biology.
So Robert Grant taught Darwin how to use a light microscope. Grant's whole purpose was, in his research, was to show a direct evolutionary connection between plants and animals. And he was working on bryozoans, meaning moss animals, but also on corals, things like that, and sea anemones and sponges. They were regular companions, and Lord knows what they spoke about when they went back and forth walking to Firth of Forth. But Darwin writes in his autobiography, when he was in his 60s, he said, well, one day when we were walking, I was astonished that Robert Grant burst into a paean of praise of Lamarck, and saying that Lamarck was right and life had evolved, but he was quite passionate apparently. And Darwin said, well, it didn't have any effect on me. I think just quite the opposite is true, though. I think that that was a very big event, and it was big enough for him to mention it. Guy who was a teacher of Darwin was Robert Jameson. He taught a course or gave some lectures, nobody knows for sure what it was, on the origin of the animal species, and Darwin was known to attend them.
Robert Jameson, I think, is a neglected Scottish scientist who's been overshadowed by Darwin and other notable figures, and perhaps his reputation suffered at the hands of Darwin. His museum was in the left-hand corner there, the upper left-hand corner, and it would be pretty much contemporaneous with Jameson himself, his tenure as professor.
So I did a PhD on the history of geology in India at the School of Oriental and African Studies.
We've got a latte here.
That's
There you are.
I went through his correspondence one day to try and find out, that they kept an animal in the Natural History Museum.
Yeah, he told me
Jameson.
that, yeah.
But there's been a lot of controversy
Oh, so
about
they really kept
exactly
it?
what species the animal.
I thought that was a myth. I didn't realise that.
Oh no,
was,
it's absolutely true.
Is it true?
And it's in the engraving, live animals hiding under the display cases. And I think Jameson says in one of his letters that at least one of the animals was an ocelot.
And he spent hours in the museum in Edinburgh, Robert Jameson's museum, which was a fantastic collection of fossils and minerals. Jameson was a pioneer in introducing field work into British geology for students, and so the students actually got some real hands-on experience.
In a footnote to the introduction of his Systems of Mineralogy, 1804, Robert Jameson laid out the main problems of natural history as he saw them as the 19th century began. For Jameson, the most important questions included: were all animals and plants originally created as we at present find them, or have they by degrees assumed the specific forms they now possess? This is the first question he mentions. He's identified the succession of species in the geological record as a problem that needs to be addressed. And he talks about transformism as a possible solution to this problem in 1804.
And if you read their things, now nobody published under their own name, there are two famous or becoming famous anonymous essays that were published in Jameson's journal, were both deeply evolutionary in nature. And it's very interesting to see there's a mixture of both Lamarckian elements, the gradual change through time, but Brocchi was equally there too, the analogy particularly. So that and Brocchi's notion that there's an internal limit to the age of species. One of the most important things, however, was in Jameson's book. He had a translation of Cuvier's Revolutions on the Surface of the Globe. I mean, there's just 4 pages of tables of species within genera and genera within families in the fossil record, and clearly showing that some genera go extinct before others. Species go extinct, but sometimes the genus keeps going. How does that happen? Well, it happens because there's a new species there that takes its place.
Stefano, I have held in my hands the 2 volumes of the Subepanine Conchologia, and it's a beautiful book, a contemporary binding. And when I asked the librarians, is there evidence that Darwin could have read this book, we looked at the register of library borrowings, the volumes for each year which listed books borrowed by students or consulted by students. And the very period that Darwin was in Edinburgh, that volume of the register of borrowings was missing and has been missing for a long time for reasons I do not wish to speculate on. Given the fact that he read widely, it's a reasonable supposition to presume that he consulted it, at least.
In the 19th century, the scientists were very careful to show they were using the correct inductive method. That's just you collected data and the theory then emerged from that. So what Darwin didn't want to do was suggest that he'd been influenced by other people's theories, which were seen as being very speculative, not really based on evidence. He wanted to show that the theory had emerged, his theory of evolution had emerged from the evidence. So it was in his interest to downplay any influence these speculative ideas had in his youth. And that's the reason I think perhaps he has little to say about Edinburgh.
His lectures were so boring, Darwin said later in life, that I determined never to take up the study of geology again. And of course the first thing he did when he got on the Beagle was to decide he was going to write the geological history of South America. So I mean, So, and again, so he's saying Jameson had no effect on him, and Jameson had an enormous effect on him. Darwin's father, I think he loved his children and everything, but he was getting tired of Darwin doing all of this other things in medical school. So he said, you still need a profession, my boy, and you shall become a clergyman in the Church of England. And for that, I'm sending you to Cambridge where you can get your degree. He gathered up two more mentors. He got particularly John Stevens Henslow, who, like Lamarck, I think he was a crystallographer at first, but he got the job in botany at Cambridge, founded the botanical gardens, became a companion. He was the man who walked with Henslow. Henslow was very interested in variation. Henslow, both of within a species in a local place, but also across the countryside.
And since I retired from teaching at Drew University, it's getting to be 10 years now. Pretty much since then, I began to work on a project that I was very passionate about, and that was to publish Darwin's scientific manuscripts. There was something unusual about the Henslow sheets in that very commonly they would have more than one plant on a page. It becomes quite clear that he has a view of what he's doing himself as a botanist, and that is looking for the limits of variation within a species in order to define a species. Now he was a creationist, so he was also very religious, but he was a creationist and thought that species have a reality, and the various forms that are produced are definitely part of the reality, but there's a limit beyond which they don't go. They don't change. Now that is something that Darwin was taught by Henslow, who actually took Henslow's course 3 years in a row.
The other person who was at Cambridge who was extremely important to Darwin was Adam Sedgwick, who was the proctor, the fierce, and he was an anti-evolutionist. He had trained himself to be a geologist, and by the time Darwin was there in the late 1820s, he was emerging as one of the great geologists of Great Britain. So here's another self-taught person with outstanding work ethics, and Sedgwick and Henslow, they just worked all the time. There were also philosophers there. I think Whewell was there. Herschel was passing through. Darwin got to know most of the cognoscenti, most of the leading lights in thinking scientifically in Britain, particularly when he went over to Cambridge. Herschel was this philosopher, was pushing the importance of Newton for all of science, basically. And he had written this book in 1830, which is one of my favorite books. It's probably the earliest coherent book on the philosophy of science. It's basically hypothetico-deductive, how you do science. And he said that book and a book by von Humboldt were the two books that convinced him that he should actually go into science.
Initially, when he was there, I think he became quite interested, especially in botany and in collecting insects, which were his main interest. But he did go to at least some of Adam Sedgwick's lectures, that's quite clear. And it was part of his general reputation as being a kind of young philosopher, as it was called.
Henslow told Professor Sedgwick that he wished that he would take Darwin out into the field in Wales, where he was doing his field work, geological field work. That must have been remarkable, because I think it lasted only a week, and I don't know if that includes travel time to get out there. And apparently they split up during the day after 1 or 2 days in the field together to cover more territory, and they would get together in the evening and chat about what they had seen. and get into arguments. And I thought that was amazing that Sedgwick thought so highly of this young man and his abilities as a geologist. And my God, he had some wonderful abilities that later comes out. That he trusted Darwin, and he also listened to his arguments if Darwin would start disagreeing. And this is all in the time of 1 week. It's just kind of astonishing to me. Anyway, it was a successful week, and Darwin's house, his family house, was in Shropshire. And that's near the Welsh border, apparently. I've never been there. And so Darwin got there, and when he got there, he found a letter from Henslow inviting him to be the companion to Robert Fitzroy on the Beagle, and also to serve informally as the ship's naturalist. He was very excited to go. This was in late 1831, supposed to leave a couple of months earlier, but the weather had been so bad. A couple of times they got a little bit out into the harbor and had to turn around. Darwin had read in von Humboldt's book a description of the lush tropical vegetation of the Canary Islands. So he was very eager to get there. In fact, he had tried to organize a field trip to the Canary Islands with some of his fellow students when he was still in Cambridge, but that never happened. From the very first stop, he was comparing fossils with the living analogs, which, you know, he had to know about Brocchi and Lamarck to even think about doing something like that. So they came to Salvador de Bahia, which was Darwin's first chance to see tropical vegetation. The mind is a chaos of delight, he said. And then eventually down to Rio, and so forth. But they spend most of their time going up and down. Bahia Blanca is right here.
Estamos en la barranca de Montehermoso, donde estuvo Darwin en 1832 y donde encontró fósiles de mamíferos. Lo fabuloso de este sitio es que está conservado exactamente como lo fue Darwin, como lo vio Darwin, hasta con la vegetación nativa y los mismos aves que volaban alrededor de la gente que recorría con él estas barrancas.
When they got to Bahia Blanca in northeastern coast of Argentina, that things started getting hot very fast.
Podemos ver los invertebrados marinos actuales, son las conchillas de invertebrados marinos actuales, que son las mismas especies que encontró Darwin en Punta Alta. Probablemente Darwin vio estos, en este lugar vio esta fauna, y de ahí los comparó con los que encontró en Punta Alta. Estamos en una cantera de conchillas del Holoceno, que está ubicada a una distancia de unos 2000 metros, continente adentro de la barranca de Punta Alta, donde Darwin encontró restos de mamíferos juntos con invertebrados marinos, principalmente bivalvos y gastrópodos.
In contrast to that, though, he saw that the bones were these gigantic, large mammals like Megatherium, which had been described by Cuvier already, so it was known in Europe about these creatures. And what was not really known, though, were the glyptodonts, which look like armadillos, but are much, much bigger, and they have this carapace of tessellated bones and so forth. He started picking up fragments, and they actually picked up a huge fragment of that.
Particularly once he starts getting to South America, that he really gets interested in this question. And I think it is, in many ways, the question of the South American mammals that really starts to fascinate him, partly because, you see like armadillos walking around. It's quite strange, he's a kid Shropshire, and suddenly you've got armadillos there, but then underneath the ground you have huge armadillos and glyptodons and other things, and you wonder, well, what's going on there?
Es una placa de un caparazón de los gliptodontes, esos grandes armadillos, y que parecidas a estas, Darwin encontró en la barranca de Punta Alta, le llamaron la atención. En principio pensó que pertenecían al megaterio, de acuerdo a una descripción que había leído de Cuvier, pero después se dio cuenta que no, que era de un animal más relacionado con los armadillos terrestres que él veía en ese momento en la región de la barranca de Punta Alta.
I think he must have had those tables in mind that Jameson had in his book, showing that there's a differential rate of extinction of species within genera depending in different kinds of groups. At Monte Hermoso, the real big action starts because he finds a fossil rodent. It's clearly a rodent. It's got a beautiful jaw. He thought it was a species lesser than, a smaller version of the living Patagonian mara. So he got excited because he thought he had an extinct fossil that was in the same lineage as the living species. So he had three things. He had living mollusks in the fossil record. He had extinct mammals in the fossil record that were clearly related to living species but were not the same. And then he had this, what he thought was one really good example of an extinct species but belonging and very close relative of the living Patagonian cavy. In November of 1832, he received Lyell's second volume, which was this attack on Lamarck's work and thinking, and he must have devoured that book. That might be the first time, although I doubt it, that he sees Brocchi's name. It was no later than 1832 that he learned about Brocchi, because Brocchi's ideas were again accurately summarized, although not fully summarized, in Lyell's books. Down there, though, at Bahia Blanca, he encounters a poisonous snake. He knew it was poisonous. It was not the most aggressive of this particular group. It's the fer de lance, and he killed one. He shot one, and he finds out that there's something funny about the end of the tail on this thing. It's a hard sort of a casque. He says it's halfway between an adder like we have in England and the European adders that don't have any structure to the tail at the end, and the true American rattlesnakes. I thought that was kind of interesting that he would still point out the anatomical intermediacy between the adders and the more perfect organ of what he called the more perfect organ of the true rattlesnake. So the Indians in South America, or whoever took an interest in wildlife, said to him, there's two kinds of ostriches out there in Patagonia. The one in the south is a little smaller, it's got bluer eggs. The distinction, kind of hard to see, but they're obviously close relatives. He was out with Conrad Martins, who's the painter, very skilled painter on ship. Guess he was also a good hunter. They were out on horseback trying to shoot Christmas dinner. And Darwin shot one of the camels, a guanaco, and Martin shot a small rhea. He was sitting eating Christmas dinner, and he picked up a bone of this rhea, and he started looking at it, and most of the specimen had been removed all the way back down to the kitchen, and unfortunately already the bones had been thrown overboard. But he said, oh my God, this has got to be this other species. It's smaller, it's this and it's that. And he went racing down to the galley, and he was able to save the head, the neck, I think one leg and a wing, something like that. The rest of it was gone. went to the Malvinas Islands, according to our Argentinian language. It was then owned by the British, and they called them the Falkland Islands. The captain told him that there was two different kinds of foxes, one on the East Falkland, one on the West Falkland. He knew they were South American in character, but they were different from island to island, and this is the first time he made that observation. So he's really seeing that isolation, separation, tends to lead to divergence, and these things, they recognizably belong to the same clade, but they are not identical, they are consistently different. About 12 kilometers up the Valdivia River is the town itself. Darwin was actually resting on the banks in a nothofagus forest when this enormous earthquake hits. I think that's when he wrote his famous essay, just called February 1835. It's the first place that he uses the phrase birth as well as death of species. He talks about the birth and death of species. He invokes Brocchi in terms of the ingrained, inborn lifespans of species. Lyell had criticized that because he says it's not like grafting trees. The grafting showed that there was something genetic about it that changed the genetics of all of the derived plants that you come from a tree that's been grafted, and they all share the same sort of propensity to die around the same time, the same ability or lack of it to bear good fruit. And Lyell said there's nothing like that I could understand that would be at the level of species. And Darwin says, why not? Maybe it's just built into the reproductive process or something. So he's actively toying with Brocchi's ideas.
I think that it is quite possible that it's something that Darwin got from Brocchi, and if he didn't get it from Brocchi, he may have got it from Brocchi at second hand in other sorts of ways. I think that a figure like Brocchi has been much underestimated just because the work wasn't really translated properly.
Wants to see compare the fauna flora of mainland South America with the island groups. The Galapagos are on the equator. He goes there. It makes no sense out of the finches. This is a confusing melange. He's not worried about adaptation. He's not doing anything like that. He's looking for patterns of replacement. That's what he's looking for. And fortunately, the mockingbirds there, they look very much like the Chilean penca, which is a mockingbird, and the one on the west coast is most similar to the ones in the Galapagos, and he notices that they're different from island to island. So he's really intrigued with that. And later on in the trip, when he writes it up, he gets to this fact. He says that if these Galapagos mockingbirds basically bear out, if they're true, the zoology of archipelagos will be well worth examining, as such patterns basically undermine the stability of species. And he went back and he tucked in the word would undermine, just in case the captain picked it up and read it. Any historian who reads that agrees that he was clearly an evolutionist by that time. And of course, I think he was, going all the way back to Bahia Blanca in 1832, but I can't prove it and I don't care. And we know what the final end result was.
If I could be transported back to one moment in history, certainly one of the moments I would really like to be transported back to is when Darwin and John Herschel were talking in the Cape of Good Hope on the southern tip of Africa. Because right at that time, Herschel is writing letters to Charles Lyell, who is a key figure in this story. And those letters are really Herschel saying, it talks about what he says, the mystery of mysteries. And that, we don't know what this law is, but the law of succession of how new beings come into being, and getting a scientific explanation for that, that's a really big and important question. And Darwin was full of all this speculation and interesting material about this, and Herschel was full of it too. It's very hard not to believe that Darwin got a certain push toward thinking, okay, I can really think about this a little bit more, in fact, quite a lot more concretely here.
But 1844, and he writes a letter to Leonard Jennings, Henslow's brother-in-law, and he had been offered the job on the Beagle before Darwin was. He writes to Jennings, I did not come to these ideas from wondering about what's a variety and what's a species. In other words, patterns of similarity and intergradation between things. That was not what drove him there. He says it's more like species or like individuals, with their separate births and deaths and so forth. That's how I got there, and that's broken.
My sense is that he's writing quite a lot of notes which are quite private, and the really smoking gun notes are, of course, famously on the very late part of the voyage.
When he was on the Beagle, and in his earliest essay, for instance, Red Notebook, when he got home, he's a confirmed evolutionist, but he's not talking about adaptation. There's no adaptation whatsoever. He started off Notebook B, which I think is the single most important thing he ever wrote, with homage to his grandfather. He called it zoonomia. And he's interested in reproduction, and he's interested in how you can get adaptation.
How are you going to take that kind of very speculative 18th century theorizing that his grandfather was engaged in, but make it so it's respectable and really fits the kind of new mode of the 19th century, really modern theorizing about that takes accounts of observations and facts.
I'm paraphrasing this. I know that there's going to be a natural law. I don't have it figured out yet, but I know it has something to do with reproduction, sexual reproduction he was thinking about, and also variation, heritable variation in organisms. So then the question becomes, when and under what circumstances in the history of a species or the origin of a new species is adaptation triggered as a process? He said Lamarck was more nearly correct than I ever supposed, and he seems more correct now in 1837 this would be. So one of the possibilities is simply you just roll the clock. Let the geological ages roll, and species will automatically, or there'll be this mechanism that will track environmental change perhaps, or whatever it is, and inevitably species will change through time. So that was one model that he had. And then he said things like, if you put the ancient ibis on a separate island, then it probably would have changed. So he was very much aware of and in favor of interpreting adaptive change as coming through, very often at least, through isolation. And the curious thing is he had lots of data for that. He had lots of examples from his field work in South America. He had no data supporting the notion that species change gradually through time, which is what Lamarck had claimed, but everybody said Lamarck had no real data to support that either. I think the main reason why it took, 30 years and certainly 10 years since Darwin was involved thinking about these things to bring adaptation in, particularly since we see it as so central to the whole question of evolution, was that the topic had been basically commandeered by William Paley. I think he wrote his book, the first edition, in 1802. It was about natural philosophy, and what he said basically was the famous analogy: if you find a watch on the beach as you walk along, you know somebody made that watch. So likewise, if you see a complex organism like a tree or like a butterfly, somebody had to make it, and it was God. So I think Darwin needed to get his ducks in a row before he could actually tackle this problem. Once he knew new species arose, He wanted to find out the natural laws behind the changes in the behaviors and anatomies, the adaptive change that actually occurs willy-nilly along with the origin of species. It's unbelievable. These two remarkable passages on adjacent pages, page 58 and 59 of Notebook E, he has his eureka moment. He's been reading Thomas Malthus, really nice passages about Thomas Malthus. Malthus points out that, at least for the human species, there's a limitation to population growth. Here he says, three principles will account for all. This is natural selection. Grandchildren like grandfathers, that's inheritance. Tendency to small change, especially with environmental change. That means variation, heritable variation. And the Malthus point number 3, great fertility in populations to supportive parents. Meaning more children are born each generation that can possibly survive and reproduce and replace their parents. It's much more, so there's something that's controlling them. There was a conflict because he did not see how isolation could occur easily enough on these homogeneously looking vast areas like the pampas of northern Argentina and the Patagonian plains, the arid plains. So he wrote to me, one of the most stunning, simple, it's a one-sentence long paragraph detailing his thoughts about this conflict. He says, if separation in horizontal direction, that's isolation, geographic isolation, is far more efficient in making species than time, which would be the gradual just passage of time, as the cause of change, which can hardly be believed, he says, then uniformity in geological formation intelligible. In other words, what we later on called stasis. What that is, it says that he's got punctuated equilibria in there. He's got isolation in geographically and then great stability through time. And if that's the model that is predominant, that's what you would expect. You wouldn't expect things to just keep gradually changing. And that would explain why there's no examples in the fossil record. But he can't believe it. He can't believe it's true. So he rejects it right there. And to me, that's the fulcrum of all of Darwin's thinking. Because after that, he mostly stresses that gradual change through time. And isolation becomes very muted, very only occasionally acknowledged in all his other writings, including The Origin of Species.
Well, I think one thing just to stress is just how radically incomplete Darwin, Lyell, and that school thought the record was. People had talked about the missing page in the Book of Life. They're talking about whole chapters missing. It's just as though you took this book, I'm not going to do it, but and you have an odd paragraph here, a little bit there. So the boundary between what they call the secondary and the tertiary period, basically between what we would think of as the death of the dinosaurs and the origins of the modern Cenozoic period, Darwin and Lyell thought that period was longer than the entire history of life since the dinosaurs. That one little gap in the geological record.
If you look at The Origin of Species, by the time he got there, isolation is just a tiny little bit of his arguments in there. It's all about this gradual change through time, and if you don't find any evidence for it, fine. That means the fossil record is poor.
He was quite slender and boyish. I mean, he didn't have the confidence of a man. I saw him grow in his competitiveness amongst people like Steve Gould and all those other guys that were in that graduate program when Niles was still an undergraduate. We got engaged to get married on New Year's Day of 1964. And at the end of my junior year at Niles, we got married.
Brachiopods are they're not symmetrical.
I understand that. Yeah, okay. I'm aware of that. And that's where I find a lot of them. And I'm surprised at how well delineated, especially the eyes are. That always just blows my mind.
Mm-hmm. But could you see the lenses on the eyes? The head tends to come off the rest of the body and go this way, upside down. In most of the stuff in the sandy facies in central and eastern New York, that's all gone, and what you have is the mud impression, and the interior is sometimes beautiful. That's what you had in what you just showed me. Material collected all over the United States, but starting here, this was the core central area. It's the Hamilton Group near Hamilton, New York. It's named for that. It's called the type section of the Middle Devonian of North America because all the rocks are correlated to this. So this becomes a very important place. Here's a couple of trilobite tails. Oh my God, great. That's really cute. I'm going to keep this one. This is good. The Hamilton Group is mostly these kinds of fine-grained sandstones or mudstones, whatever they might be, usually highly fossiliferous. There's, I think, 500 or 600 feet of rock, all stacked up. And go through time, maybe 5 million years, maybe 6 million years. It's hard to be exact. But the fossils are fundamentally similar all the way out throughout the section. It's a marine vertebrate fauna. It's called the Tropodoleptus fauna, and it's got lots of brachiopods, lots of clams, lots of snails, and 3 or 4 species of trilobites if you get lucky. Wow, look at this one. Ah, that's fantastic. More or less the same species are found throughout. There are some exceptions, and but the interesting thing is none of these fossils seem to change through millions of years of time. None of them do. And we always assumed that if you had that much time and a good collecting, which is what we have here, you would inevitably find gradual change in your fossils. And so I was here. I was looking for that kind of change. And it scared me that I couldn't find it. I was doing my PhD, and you need positive results. I couldn't find it. Since the 30s, people like Ernst Mayr and Theodosius Dobzhansky particularly started to once again stress the importance of geography and geographic variation and isolation in the formation of new species. After Darwin finally got off the stage, but his books were out, he was being discussed, a hiatus of about 75 years where isolation was barely addressed by people talking about evolution. But by and large, that whole theme disappeared from the scene. So it was like a long period of dark ages. So the hiatus was abruptly broken because of the genetics laboratory at Columbia University, Thomas Hunt Morgan's famous fly room, where they discovered genes on the salivary glands of fruit flies, Drosophila melanogaster, and the fact that genes are on chromosomes. That was a very important discovery. So here's a guy who's a systematist. He worked on ladybird beetles, but he had a hankering, a desire to learn about the genetics, and he had a background with a teacher who was interested in evolution.
He was a naturalist. In fact, he was a taxonomist of beetles, of ladybird beetles. He was invited to come to the United States with the help of a Rockefeller grant. And he went to Morgan's lab in Pasadena, and he now became acquainted with the thinking and the methods of the geneticists. He certainly saw how he could put the two things together.
In 1935, he published a very short paper, and he says basically nobody's been looking at the most important evolutionary phenomenon, which is that there are gaps between species. Dobzhansky said, well, there are what he called isolating mechanisms, but it must start with physical geographic isolation, or at least that would be the easiest way to imagine the beginnings of that kind of isolation.
He provided the basis, then published in 1937 in a book called Genetics and the Origin of Species. He provided the necessary basis.
Very important book with all of this material in it and a lot more data, but that was the gist of his ideas, and that species are discrete and they become discrete through a natural process.
I was born in a little town in southern Bavaria, the town of Kempten, on the 5th of July 1904. This means that I'm now more than 93 years old. While I was at the American Museum, I was interested not only in bird taxonomy, but also in other aspects of birds. For instance, I discovered that there was a geographic variation of degree of sexual dimorphism, and Dunn invited me to come to seminars to Columbia University, which I did. As I was going, and I became more and more friendly with the department there, and then Professor Dobzhansky arrived from California, from Pasadena, and I invited him to come to the museum and study my wonderful cases of geographic speciation in birds, and he was quite excited about this, and I was excited about his lectures.
And it was actually Meyer who gets the credit for coming up with a definition of species as reproductive communities. But as I say, that was really Dobzhansky, and for that matter, it was already there in Darwin, in the old Darwin, but they didn't know what the old Darwin said in his notebooks. There was one other sort of event, one person that should be mentioned before we start talking about the punctuated equilibria, and that would be George Gaylord Simpson, also at the American Museum of Natural History. Simpson always remained a gradualist. He said, well, while the importance of isolation is been well established, basically he didn't care about it at all. So why am I talking about him now? Simpson wrote Tempo and Mode in Evolution, and it's about the paleontological perspective on evolutionary matters. But he had this attitude that what happens to 100 rats in the course of 10 years under laboratory conditions is likely to be rather different to what happens to millions of rats over millions of years as you go through geological time. And what he had in mind was the relatively abrupt appearance of large-scale groups of organisms, like mammals, or like whales and bats are famous examples inside the mammals. Because once you get a bat in the fossil record, it's a bat, and it has that complex anatomy. They're primitive in many respects, but the basic adaptations, the thing that makes them bats, is already there. You can't just extrapolate a gradual thing, because these orders of mammals would have had to, if they all evolved just slowly and gradually, way back in the Mesozoic, and there's no fossil evidence to support that. So it indicates that there were rapid bursts of evolutionary change. He said it even applies to species, but he never really talked about that. It was just these large-scale groups that he felt needed some special explanation.
Macroevolution, that means the evolution of higher categories, of higher types, of evolutionary novelties, of all the things that go over long periods of time, and that, for instance, also interests the paleontologist.
The bottom line for us kids was that the fossil record can be trusted and has a real signal in there, and we should go ahead and see what we can see about evolution in the fossil record. I got to know these rocks and fossils through Bud Rollins, who was he was 2 years ahead of me in graduate school. He's a paleontologist. He's from up here, and suggested I work on this trilobite phacops instead of the snails I was working on, which are more simple. We thought maybe with a more complicated anatomy that trilobites have, that it would be perhaps easier to find some evidence of evolutionary change.
Look at all the breaks in Rugos'
Right.
interruption.
Had a rough life.
Rough life.
Things were tough in the Devonian.
When I was at Colgate as an undergraduate, Bob Lindsley, who was a remarkable teacher, was interested in the Anderdon limestone in Michigan, and he came to join Colgate, and I tried to convince him that there's a wealth of stuff around here.
Right.
And I took him out. Pretty soon he slowly never gave up the Anderdon, but he collected with me all over central and western New York. Bob was remarkable. He'd find a trilobite, and all of a sudden it would disappear. And he'd have it in his cheek pouch. And he'd dig it out later. Oh, look at that. It was amazing. Very inspirational teacher.
Trilobites have heads, they have middle bodies that are flexible, segmented, and then they have a tail at the end. And the great thing about Phacops is that it has eyes that preserve beautifully. And big lenses, so you can count the lenses and so forth. And that turned out to be the whole trick to understanding the evolutionary history, basically, of this particular group of species.
Boy, was he serious then, and determined, and focused, and he studied like crazy and worked very hard, giving himself eye strain, measuring all these columns of eyes on the trilobites, on the Phacops.
My big eureka moment came when I realized that with the kinds of data on the eyes that I was copying the format from Ewan Clarkson's, I had different populations. We had 17 columns of lenses in the eyes. I defy anybody to show me a trilobite from here with well-preserved eyes that does not have 17 columns of lenses. Going into Ontario, southern Ontario, and also Michigan and northwestern Ohio, we found specimens with 18 columns of lenses. Not only was this trilobite stock, the species, derived from the Old World province, but there was some evolution going on once they got here. So the ancestral form, I concluded, lived on in the clearer waters of the Midwest. It was all flooded by ancient seas. People don't know that, but the sea was covering much of North America then. And it was here, closer to shore, with these muddy conditions, that we see a change. The older Hamilton rocks all have 18 columns of lenses in these particular trilobites. Then the sea withdrew from the continent, so everything in the Midwest became extinct. Everything lived here in this basin, the Appalachian Basin. When the seas were flooded back again into the continental interior, these were the ones that came out because the other ones had been driven extinct. So in the Midwest, you get a pattern of 18, and then 17, and then finally, at the very top, 15. In the late 60s, when I finally figured out my story about what happened to these trilobites and how they evolved in sort of basically jumps, and they would be stable, but then they would then have a little event, speciation event, not a huge amount of anatomical change, but from one state into another state, and recognizable. They persisted that way for a long period of time, and also geographically for a long period of time. I wrote a paper up, the first draft of which I sent to some of my friends. I gave it one to Bud Rollins, but also Steve Gould had already gone up to Harvard in 1969, I guess.
Well, the first thing that he wrote, which really he laid out everything before he collaborated with the great Barnum and Bailey promoter, Steve, he wrote the same paper essentially, and he launched it on the world, and it sank without a trace.
Steve Gould had already gone up to Harvard, and Steve was a dynamo. He was very interested in evolution, but he was also very interested in getting going on publishing. And why wait till you're 60 and before you start thinking about these things and publishing? I used him as a role model, just as I used Bud for the rocks and the fossils, and he was an inspiration to get out there and believe in yourself and think about these things.
On the land of
The paper was published in Evolution, which is a strange place for paleontologists to publish, but I thought it was of greater evolutionary significance. So before it came out, I got a phone call from Steve saying there's this book that's being organized by Tom Schaff. Tom's idea, and I think it was a good one, was to try to get more conceptual thinking, theoretical thinking, injected into paleontology. Steve was very interested in morphology and also patterns of development. And that was his first choice. He wanted to do growth and form, maybe even systematics. But those titles had already been given. The closest thing to what he wanted to do was on speciation. And he called me up and he said, I really want to be part of this, but I don't know what to say that's not already in your paper that you sent me. He said, would you like to join? And I said, sure. That would be an honor for me and a wonderful opportunity. So he said, all right, fine. And he said to me, I'll give the paper in Washington and be senior author of the abstract. Because I know that you're nervous giving papers, which is off and on true. And that's true enough. And you can be the senior author on the paper, which is really one of the dumbest things he ever did. I said, deal. It's a deal, you know. So I wrote a new manuscript, and he took that, and it's pretty much intact with a little bit of improvement in the writing in the middle section of the Punctuated Equilibria paper that we published in 1972 in Tom Schaff's book, Models in Paleobiology.
So Niles retired in 2010, and he was able to retain his office for some years after then. So only in 2014 did the bulk of his papers come to the library. I think he might have been saving some of his more critical materials in his home library, but then wanted to have everything in one place. So he passed them over to us.
Niles gave me the very first draft of the paper, which he had written. And then I was able to compare that to the subsequent drafts and then the final product, and actually to go through and identify precisely who contributed what. I sort of block out with different colors which author contributed what. And the way they collaborated was to send the drafts back and forth to each other. But, you know, Niles wrote his portion and then Steve wrote his portion. But what Steve added later is Steve. And you can still see, though, entire paragraphs, even pages, that are from basically verbatim from the original draft that Niles wrote, that are then surrounded by this additional prose and argumentation that Steve contributed.
Especially in those days, people wrote for the field. They didn't write for a popular audience. And the more abstruse and recondite your vocabulary, the better. But then, of course, it became impossible practically to dig out what the significance of something was. If he didn't have a talent for self-promotion, well, Steve came into his life to take care of that. We had dinner with Steve and his then wife, Debbie, and we were parting ways because wherever we had rendezvoused, it was probably some restaurant in Broadway. We were going north, they were going south. They lived a one stop south of us. That was when Steve had tried to assert some greater dominance in the presence in his amount of input to what Niles always refers to as punk geek. We're on the uptown side of the IRT subway platform, and Steve and Debbie are on the downside. And if looks could have turned into darts, Steve would have dropped down dead at that moment, because Niles, whether this was the moment that Steve really tried to gain proprietorship or whether it was just looming, I do remember Niles was really bent out of shape.
The picture that emerged to me was that quite clearly the theory was Niles. And I don't think that Steve, at least at that time would have argued with that.
But other than that, he and Steve were always really tight, and they got along, they understood, and I think they really helped each other, you know. And of course what they say about academia is it's all about the reputation because there's no money involved, so everybody fights even harder over the reputation.
Steve saw as well as I did, that there were some implications for punctuated equilibria. We essentially reinvented the geometric depiction of the history of life. Instead of gradual change and everything, species with these dark black lines stay more or less the same as they go through time. There can even be relative survival of species, so you can get directional change through time, sort of like a species level selection effect, or there can be no real accumulation of change. These are axes measuring anatomical differences between species. But we're talking some of these maybe only lasted 1 million years or hundreds of thousands of years, but some of them lasted for millions of years. Selection of species, differential survival and or production of species, that would be like a species selection. Steve Stanley actually gave that name. There was a whole discourse on species as individuals by Michael Giesland. It had nothing to do with our paper, but he was saying species are individuals. They have, births, histories, and deaths, just like individuals do. That's the reinvention of Brocchi.
I think it's only in recent years that Niles is willing to let the information exist separate from the man. So everything has shaken down into place. But I think it's been a lifelong effort for Niles to feel comfortable with both his acceptance and with his non-acceptance. So I think we've come to a stable platform at this point. But was it troubling? Yes. Was it exciting? Absolutely.